Chief guest.
A very warm good morning to one and all present here. It is very great pleasure to introduce the chief guest, Dr. Shajulin Benedict, sir, guest professor, Technical University of Munich, Germany, faculty in charge, research and development and international affairs, Indian Institute of Information Technology, Kottayam, Kerala. He has completed his undergraduate BE from Manoormaniam Sundarnath University, India with distinction. In the year 2004, he has received ME degree in Digital Communication and Computer Networking from Arulmigu Kalasalingam College of Engineering, Anna University, Chennai. He has received second rank in his master's degree. And also, he did his PhD degree in the area of grid scheduling, Anna University, Chennai, under the guidance of Dr. V. Vasudevan sir, Director, Software Technologies, Group of TIFAC in Network Engineering. He was affiliated towards the same group and published more papers in various international journals. After his PhD award, he joined a research team in Germany to pursue his postdoctorate under the guidance of Professor Jen. After that, he served as a professor at St. Xavier's Catholic College of Engineering, Research Center of Anna University, Chennai. Later, he visited Technical University of Munich, Germany for teaching cloud computing as a guest professor. Now he works at the Indian Institute of Information Technology, Kottayam, Kerala. He serves as Director, Principal Investigator, Representative Officer of AIC Incubation Center, IIIT, Kottayam, for nourishing young entrepreneurs of India. His research interest includes high-performance computing, cloud, grid scheduling, performance analysis of parallel applications, including exascale, cloud computing, IoT, blockchain, and parallel compiler. We are so glad that such an eminent person is in the midst of us as the chief guest. Once again, we welcome you, sir.
Thank you, ma'am. I profoundly delighted to take an opportunity to invite the chief guest of our conference, Dr. Shajulin Benedict, guest professor of TUM Germany and faculty in charge R&D and International Affairs, Indian Institute of Information Technology, Kottayam, India, to share the few words.
So good morning to one and all. It's in fact an immense pleasure for me also to share some of my ideas here. Let me first share the screen. I hope the screen is visible to you.
Yes, sir.
Okay, so today I will be talking about serverless cloud based remote healthcare monitoring. So obviously, lot of mobile devices as well as edge-based devices are typically used for healthcare monitoring purposes. So I will be covering a very base ideas relating to this, and I will drive you towards serverless concepts. Yeah, I would like to share a few words about Technical University Munich, Germany. In fact, this is a very interesting university in Germany. If any one of you would like to pursue your higher studies or something, it is better to apply and go to this university. The flow of the talk will be like this. First, I will explain the base of IoT, some divisions that come under IoT, and then how remote healthcare monitoring is essential and how it can be applied using serverless. This is how the flow of my talk will be for today. As it's hot today, Internet of Things is definitely very interesting and a versatile technology that brings a lot of innovations in this field. If you think what is Internet of Things, it's just an extension of Internet. Okay, you have an Internet currently, and this Internet is extended to several things, right? Earlier we had Internet only for servers, laptops, mobile phones. Nowadays we need to have this Internet also to things like It can be like fan or table, chair, and so on. No, also some in-body devices or out-body devices, some electronic-based devices, small things which need to be connected, right? So as everyone would agree, the number of devices keep increasing day by day. So therefore, it's a kind of future internet. Millions of computing devices, then personal devices, as well as objects, sensors are connected. So this particular internet, the future internet, is going to be very challenging, and you can expect like a lot of research dimensions could be solved based on this. That's why a lot of products are coming up. Entrepreneurs are interested, business people are interested, because you can easily convert a normal concept into innovative product. Innovative product is innovations are not just not something extremely difficult, right? You have to rethink how the existing technology can be put to some commercialized way, right? So Internet of Things is playing a major role. The thing, when you connect things, when you connect a lot of objects together, you can create a smarter society. You can get a lot of knowledge, right? As no, I think Dr. Mohammad Sadiq was also mentioning, right? So he was also mentioning like lot of new things would happen in very near future. Robots will be the reality in the later stage. You can get a virtual marriage. You can get married to some women. You can stay with some characters, but virtually, and you get enjoyed or keep productivity level little higher in this field, right? Sometimes there are always possibilities that because we don't like the characters, our productivity level goes down. But if you know, in the future, if some robots, some virtual techniques, IoT based techniques, where the objects or things are communicating and making the robots to play around, there is a high chance that the productivity level of human life will increase a lot. And think about knowledge-driven society like agriculture, farm, or something. A owner will get a lot of information about what is happening in the world. So, when you get a lot of knowledge from sensors or objects around, you are very, very calculated. You can easily get a good revenue also, right? You can get a degree from some Stanford University or Harvard University by using the laboratory at your sitting place itself. So these are all trying to make the society much, much smarter and keep the people more productive and knowledgeable. So in short, all these devices need to get connected, right? And all these devices know how to provide whatever knowledge it can provide, and by this way the revenue should increase. So in short, this is just network of physical objects that contain embedded technology to communicate and sense, interact with other internal states or external environment. It's basically an extension of internet, right? So why we need to really think about this, right? So you can see like the trends keep increasing. Patent filing also keep increasing every now and then with the keyword search of IoT. You can observe that. Also, funding is very, very high. You can notice here like the market is having a very potential revenue in the future, which shows that an entrepreneur or a researcher, if he wants to dive into this particular field of research, right, he has a lot of possibilities of growth, right? He can invest something to get benefit out of that. So without funding, nothing will work. Without funding, you or myself, we cannot do something, right, productively. So This chart shows that productivity will keep increasing day by day, and this can happen with these technologies in several domains. Basically, like if you see smart city, connected industries, connected building, connected car, smart energy, connected health, smart supply chain, smart agriculture, smart retail. So many different sectors here. I'm just pointing out different domains where you can apply IoT as well as edge intelligence. It is the need of the hour, basically, to think the utilization of IoT. Although today's talk I will be covering more about remote healthcare monitoring, it is also equally important for researchers to think in different directions, like smart city, a city with all infrastructures and everything. But in addition, the people or citizen living in a smart city environment should get additional revenue. He should be motivated to get more revenue while he lives there and keep him more productive. Connected industries, lot of industries hereafter can become like a connected one, because one machinery can talk to the next machinery saying that the role what I have done is complete, now I need so and so things to be done in the next machine. So machines are talking to the next machine and making things faster, right? Connected industries become more and more popular. Smart agricultural, nowadays people just use mobile phones or some camera attached edge devices, just to show in front of the trees, and they calculate how many fruits are ripe. Right? Think about mangoes. Uh, for example, just you show the camera attached device, maybe your mobile phone or something, right? And this immediately calculates how much revenue you get today, right? Show it to guava plantation, and immediately it has to tell you how much revenue you would get today, right? Or you can even fly drones, right? Repeatedly in an automated fashion, which will just capture the images, make all sort of processing, right? And get the intelligence, prepare the summary of what you want, and send the details just to the owner, where the owner need not go any time, right? Let it be kind of any disease happening, or what kind of pesticide you have to provide, whatever you want to do, all this could be done with the help of IoTs. Lot of industries are working on this field of research, and you can observe this from innovations that they do, right? Patenting, how many patents do they file, right? Samsung, Qualcomm, LG, all these companies. Even if you go to a company, if you work with a company, you are urged to do some sort of innovations, which means transforming the technology to commercialized products. So in very short form, what this IoT does is, it has sensors, actuators, as well as networked devices. So sensors are going to sense whatever you want to sense, and then you will have some networked devices. When we say networked devices, it could be a cloud. So sensors are sending some sensed information to cloud. Cloud is doing some sort of processing, and based on the inference, based on what reasoning it has observed, it has to send back the information to some actuators. So actuators are basically doing some action. It is performing some action. What kind of action it can do? Like even sending emails is one kind of action, or rotating a motor is an action, or switching on off a device is an action, right? So send something, do some sort of intelligence, perform some sort of intelligence. Networked devices should do that, and then action should happen. So very bird eye's view, if you see, IoT devices are having this kind of structure: sensors, actuators, as well as network devices. Now, there are so many sensors, different types of sensors: temperature, lighting, checking the light conditions, humidity, body checking, sensors, and so on, so on. So many different types of sensors are there. Different types of actuators are also there, and some network devices that are going to do some action is some sort of computational part, right? Typically the sensors attached with some small computational unit like Arduino or espressive CSP, or maybe even little bit more like microprocessor based Raspberry Pis. They can send information after sensing and processing, and it can send it to the cloud directly, and cloud can do the processing, right? Today's our discussion is more focusing towards remote healthcare monitoring. We have understood what Internet of Things mean. It is future internet, just internet, right? And when we connect a lot of remote things or objects or sensors and actuators, we can get lot of information, and we can perform lot of action. So this is very clear to us what IoT mean, right? How this IoT plays a major role in a particular sector of application, which is remote healthcare monitoring. Healthcare monitoring is very simple, right? We can attach some sensors, and we can send the detail of what happens, right, and make some intelligence out of that. Remote healthcare monitoring became more and more popular only after COVID, actually, because we all were locked down, locked inside our house for almost like 1.5 to 2 years. And think about patients, right? A lot of patients who had regular visits to hospitals were unable to go. And no, this gave some sort of innovation. It gave birth to innovations because doctors as well as solutions started to come up with remote healthcare monitoring, remotely assessing as well as monitoring the health, or remotely doing some sort of health check, remotely performing operations, which is more robust ones, right? But we want to understand here, the remote healthcare monitoring is getting more and more attraction these days. So if you see this architecture, a very simple architectural explanation of what remote healthcare monitoring mean, you can you can see sensors will be there, actuators will be there, right? And patients who are either in hospital or at home, they are connected. Basically, they are connected with the networked device, as well as hospitals and the other units for making some intelligence out of the sensed data. So sensors, actuators, as well as network devices. So our concept of just sending data to cloud, and cloud performing some action or making some reasoning is something people these days doesn't like. Because if you want to send videos or pictures of a patient to cloud is typically a third party provider, right? A public cloud is like leading place like Amazon or Alibaba or Google. These are all third party providers. So your information is sent to cloud, a third-party provider's network storage units or somewhere, is not much accepted, right? Because of privacy, first issue. Second issue is because of latency and other bandwidth constraints, right? So when you tech network device, it's not just cloud. We have to think about fog or edge. So fog is somewhere between edge as well as cloud, and edge is some computational unit which stays very near to the sensors for making some sort of processing the sensed data. So if you do some sort of analysis, little analysis to the sensed data, and if you make some sort of filtering or process, little processing of data, we can do that in edge itself, right? To the device or computation unit which is staying very near to the sensors, you can do that. So that is one attraction, right? So you are not flooding the data to cloud and make the communication, or make the decision on cloud. You split the computation in a hierarchical fashion such that edge, then it goes to the fog, then it goes to cloud. So you have several levels of analysis, right? Like diagnostics of or prediction of whatever health issue you have. You can do that in levels. So in such kind of health monitoring architecture, one important aspect is user interface. You need to have a very good responsive design or interactive kind of boards, right? Automated software boards which will keep you psychologically happy. And you should also have some responsive designs, right? So when a patient is, say for example, he wants to see what is the status, right? The visualization pattern of your design, the user interface should be more attractive for the patient. Sensors are there, actuators are there. I have mentioned about that. The sensors or actuators could be of different categories, like in-body device or on-body device or portable device, right? Because in-body devices are also becoming popular these days, like um, diabetic patients may need insulin pumps, right? So the pumps will be there in your body, and this will be this will inject insulin time to time based on the sensed blood sugar level of the body. Similarly, cochlear stimulators or neurostimulators, these are all in bodies devices. You also have sensors that are attached on body. So some examples are like pedometers, wristwatches, right? Some dresses are available nowadays. Textile industry is also adding up IoT based systems, because think about some elderly people. They always break their hip, or mostly hip, at the age of 80, 85, because they cannot walk properly and they fall down. So if you have some sort of sensors that will detect this angle differences, and immediately the fall detection is noticed, and the textile will be there such that it creates like a bag, airbag structure. So action happens based on the sensed data. Some intelligence is performed, and immediately fall is detected and the airbag is opened, right? When airbag opens, he falls down but nothing happens to him, right? So these kind of devices are becoming popular. Also, many people after the age of 45, 50 get spinal cord problems, especially computer professionals, right? So these people also can be prevented by some notifications sensed through some sensors. There are 4.5 meter sensors or 2 meter sensors to detect such kind of positional change in your spine. So these are all sensors that are applied. Static devices are there, ambulatory devices are there, hospital devices are there. So in principle, there are so many sensors, right? Glucose monitors, temperature sensors, heart rate monitors, oxygen pulse monitors, movement disorders, stress indicators, posture indicator, lung status indicator. So depending on so many applications, you have so many sensors as well as actuators. You should mostly focus on the computational part also. As I told, you are not sending the data directly to cloud. We have to have some sort of hierarchical computational structure, especially edge. right? Edge is very, very important for improving the privacy as well as latency of your system, right? If you want to integrate AI, artificial intelligence, the intelligence should not only happen on cloud. It should happen right from the edge device itself. So there are so many technologies like federated learning as well as transfer learning aspects and so on, where you can distribute the deep learning algorithms to learn with the data on edge, and only the synopsis of what you get will be transferred to cloud for long-term predictions and so on. So in short, we need to have hierarchical layers for these kind of things. As I told, edge is very important these days, are becoming very popular these days, and there is a separate research community working on this edge intelligence. So to reduce network bandwidth, response time, to prevent the local data, also improve the security as well as privacy, right? So I have told that cloud is there. Instead of cloud, we can bring edge, right? Edge is also important so that you get privacy as well as also the other network bandwidth efficiency aspects. I'm also trying to introduce another one more concept called serverless. So serverless is a concept, is an execution model that is applicable in cloud environments these days. So what is this serverless mean is the server is not powered on all the time. Think about a remote healthcare monitoring application. Okay, you need to remotely monitor a patient continuously, and this can sometimes prolong for years. Think about a patient, he started at 50 and he may live for 80 years. Your application may have to execute or run for 30 years. A cloud is used. So if you are using cloud, you have to pay the service, cloud infrastructure service, for 30 years, which is not economically viable one if you take a long journey, right? So what is better is to have serverless. So in serverless, what happens is only when some data needs to be updated, or only when some data is need to be processed based on the sensed information, the server is searched in cloud, and then the server is started booted, and then it is executed. So server is not available only when the data is triggered, only when based on some sort of event trigger, the server is starting, right? Server starts. So this means you are paying only for very, very limited time, right? Think about a periodic application of remote healthcare monitoring. You want to monitor the blood sugar level every, say, week of one chronic patient. So instead of paying cloud for 30 years, what you do, you are going to pay only for 5 minutes of the experiment that you do, right? 5 minutes, your sensor unit is checking the blood sugar. It is going to update it, making some sort of intelligence at edge level, like kind of filtering, and then sending the data to cloud, and cloud is just updating the visualization pattern, sending the reminders to concerned hospitals or hospital records and so on. This could probably take only 5 minutes of work. So you have to just pay only 5 minutes of your amount instead of paying 30 years, right? 30 years, but 5 minutes, maybe like weekly once or weekly twice, or whatever. It is very, very less in amount, right? So serverless is very helpful. And here I have listed, like, how different ways you can monitor or remotely check the health status of a patient, right? Depending on computing, we can classify them. Depending on priority of the task, like are they periodic healthcare monitoring one, or whether it is like very urgent kind of thing, like for example some cardiac related issues are there, then the priority should be high, and how to handle this or how action should be taken by the microcontrollers or associated edge intelligence patterns is differing, right? Periodic task or handling periodic task will be different, and based on communications that are involved, like some remote healthcare monitoring applications can use Wi-Fi, some can use 5G, some can use LoRa, right? And some can use different other communication methods, including Zigbee or whatever, right? So depending on communications involved, we can classify the healthcare monitoring based on accessibility. Like, are you accessing this remote healthcare only in some connected hospitals or globally, right? Whether the patient is treated by multi-speciality different hospitals across region, or whether he is treated only by the concerned group of doctors belonging to one hospital organization. So accessibility features differ, and depending on that, the remote healthcare monitoring techniques also differ based on how good the intelligence that you offer, whether it is like a more diagnostic approach, or whether you are just saying that something is there or not, or are you going to predict and say this kind of health issues or concerns might happen in the future, right? Depending on what kind of intelligence do you perform, so accordingly the learning algorithms differ, and the pattern of data that you apply will differ, and so on. So you can see here some classifications of how you can apply remote healthcare monitoring. And to really implement edge intelligence, you need to have some sort of tools, typically for learning, or for performing some deep learning intelligence or any kind of intelligence. People can use a very good framework, TensorFlow. Uh, but this require a lot of computational power, as well as it also requires a lot of packages to be loaded and experimented. Typically cloud kind of scalable computing environments can only apply them. But if you want to use some edge devices, it is better to have some other tools in this series itself. It is called TensorFlow Lite, right? You can have a note of what this TensorFlow Lite could be done. So in short, what we have learned so far is remote healthcare monitoring is one of the IoT based which is becoming very popular these days, after especially after COVID situation. Now all hospitals who have implemented this remote healthcare monitoring approach are practicing that regularly. So this is one among application, and as I told, IoT is getting very, very popular, and there are a lot of scope in the future. And when I said a normal IoT, the data is transmitted to cloud. Instead of that, you can also apply intelligence at edge level. So edge intelligence is very, very key concept these days, and not just directly applying cloud. We could also incorporate the serverless execution, cloud execution model, which can save a lot of cost involved in your application. So there are so many good works that happen from our IoT Cloud Research Group here, and with association with the Technical University Munich, we are also managing to do certain things. Before I close the keynote, I would also like to inform you about two incubation centers that we have, where we are specializing in IoT related topics, and we promote startups, or we promote ideas who are willing to convert the research ideas to patentable products or to real products, marketable one. And in that case, there are some provisions where 2 incubation centers are able to provide some money for developing these ideas. So you may be interested in that. And I'm also extending my willingness to support with join certain things. I would also recommend you to read this book, which is published from UK, Deep Learning Technologies for Social Impact, where I have also covered some portion of IoT-based systems. So with that, I once again thank all authorities, especially Principal Sir, as well as Dean, or general managers, chairman, as well as HOD of ICICV 2023 conference, and also to all speakers, researchers who are presenting your work today. With this, I thank once again everyone, and all the best for the future days.